AI can generate database code in seconds, but it cannot prove it's correct. And that's where most teams get into trouble. This is deCoded, where we break down AI engineering patterns, not just how to generate code, but how to validate it. Today, we're looking at how to teach a coding agent how to debug and validate Supabase. AI-generated code often runs without errors. You get a return of success, it passes basic tests, but it doesn't mean it's correct. The most dangerous failures are silent. Silent inserts, broken row-level security policies, schema drift, and no one notices until production. Silent success is dangerous, and that's the problem we're solving today. So most AI workflows look like this: prompt, think, code, and deliver. And there's no structured validation loop. So the output is always assumed to be correct. And in an evidence-based model, we introduce a reference skill. We validate, we refine, we confirm, and only do we deliver with evidence. That's the difference between generating code and engineering systems. Today, we'll apply that model to Supabase. We're going to look at 3 common failures in AI-generated Supabase. First, silent inserts, where no row evidence is returned. Second, false row-level security validation, where a service role success hides broken policies. And the third is schema drift. That's where the database changes, but TypeScript types don't. And we're going to enforce validation on all 3. So we're going to start off on our local instance. We're running this in cursor. So need for setup, we're ready to go. Here we run an insert without a select or without throw on error. And Supabase returns a data null or error null, so it looks successful. But with no row evidence, nothing is returned to prove that an insert actually happened. So a skill fails it immediately. And if you can't prove that the row was written, it's not done. Now we're going to require a select, single, and on-throw error, and we're going to run the insert again. This time we're going to get a real row ID. That's observable, it's verifiable, and the difference between code that runs and code that proves that it worked. Now we show the diff, not just runtime behavior. It's an actual change enforcing validation. Evidence isn't just output, it's traceability. No evidence, it's not done. Now we're going to enable row-level security, but we intentionally don't add an insert policy. So anonymous inserts fail with row-level security violation. That's expected. So far, so good. Now we're going to try the same insert using the service role key. It succeeds, and for most demos, we'd stop there and say it works. But service role bypasses row-level security, right? That's not proof of policy correctness. It's proof that you used an admin key. So the skill explicitly warns us of this. Now we're going to add the correct policy. Authenticated users can insert with a user ID and auth user ID, and we're going to rerun all of our scenarios. Anonymous still fails, authenticated succeeds and returns a row ID, and service role succeeds, but we don't really count that. That's validated security. Now we're going to introduce schema drift, and we're going to add a column to the database, but we don't regenerate TypeScript types. So the database and application types are now out of sync. So the skill compares the database schema to generated types, and it fails. The type drift is detected. It's subtle, but it's a very common AI-generated work. Now we're going to regenerate types. We're going to show the diff, and the new column appears as a type definition. Now the system is back in sync. When we rerun the drift check, the schema and types match. Validation complete. Remember, no evidence, it's not done yet. So across all 3 scenarios, the pattern is the same. Fail, fix, prove, show the diff. It is not magic. It's one validation pattern applied consistently. So AI can generate code, but it doesn't automatically generate proof. If you're building AI in production systems, especially around data and security, validation must be enforced. No evidence, it's not done. Now, if you want these validation patterns in your own Supabase project, you can install the skill directly with the repo listed here. And you install the skill by going to npx skills add visaoenhance / supabase-debug-playground, and enforces validation requirements before delivery. You install it once, you enforce it everywhere. If you're building with Supabase and AI, link is in the description. Please install it, try it, break it, and if this down was useful, subscribe to deCoded, because AI can generate code, but you still have to prove it works.